I welcome you all to the last lecture of this forming process of Unit 5. So, in this lecture, we are going to discuss about the rolling operation. So, rolling operation is a metal forming operation in which the thickness of workpiece is reduced by means of compressive forces exerted by two rolls rotating in opposite direction. So, you can see the diagram here. These are the two rolls that are rotating in the opposite direction. You can see if you consider this is anti-clockwise, so the other roller is rotating in clockwise direction, and this is a slab which is inserted from the left hand side, and it's coming out from the right hand side. So by applying compressive load, we reduces the thickness of the sheet. So this is what we call rolling operation. So flat rolling operation is shown here, and similarly there are other types of operations are there, such as I beam and L beam. I beam that we use in our rail tracks, and the slab or the workpiece specimen that we use in rolling operations are of different categories, and we can term them as bloom, slab, billet. So if a workpiece or a specimen is in a cross section of 150 into 150 square cross area, so it is termed as bloom. And slab, it is rolled from ignat or bloom. You can say ignat. You have seen this part in extrusion operation, or you can say the for when we are talking about the forging operation, the the part that we keep inside the die is called ignat, and or you can say it is also formed from bloom, that is rectangular cross section of 250 width or more, thickness of more and thickness of 40 or more. So just go through this terms, and we have diagram of this bloom, slab and billet in the next slide. So basically, bloom is what you can see in next slide. This is the bloom, a big cross section area, and this is basically used for the purpose of for making an L or I type of cross section, I section or L section. This is basically used in rail tracks. So this is what we say bloom, and the dimension of this bloom was mentioned in the earlier slide, and this is what we call slab. So slab is nothing but a sheet with having certain amount of thickness, and these are basically used for making thin plates or coils. And these are the billets. It is a long structure with the square cross section, and this is basically used for making bars or cylindrical rods. So these are the specimens that we use in rolling operation, and with the help of rolling operation, we produce such kind of final product. So all the definition and uses of these billet slabs are written here. You can go through these lines. Now the plates and sheets are further reduced in thickness by cold rolling. So we have discussed in our previous lectures about hot and cold working. So if I'm talking about cold working, it means the temperature of the working is very less, is near about room temperature. That is called cold working. So in terms of if we perform cold working, then there is no oxide formation, there is no any scale formation over the material. So the quality of surface will be better in case of cold working, that is written here. The important advantage is that the surface of cold work sheet does not contain any scales and generally superior to the corresponding of hot rolled product. In hot working, what happened? The temperature is higher than the recrystallization temperature, and at that temperature oxide formation starts, and due to that the property of surface deteriorates, and this is why cold working is better as compared to hot working in terms of surface properties. Now the roll mills. Roll mills are the rolls that we use. The combination of rolls that we use in rolling operation are called roll mills. So basically, we have different kind of roll mills that we use in our industry. So firstly, let's start with the two high rolling mills. So this is the example of two high rolling mills in which the rolls rotates in opposite direction here, And we have two types of two high rolling mills. One is the non-reversal mills, other one is reversing mills. So firstly try to understand what is two high rolling mill. If somewhere is written that we two high rolling mills, it means that it has two rolls, and the workpiece is coming from left side and coming out from right side in this way, in such way. And the roll diameter is between zero point 0.6 to 1.4 meter. And now we need to know what is the reversing and what is non-reversing. So let's start with non-reversing mills. So in non-reversing mills, rolls rotate only in one direction and slab always moves from entry to exit. So if we take example of this diagram, if it is non-reversing mill, the direction of roll 1 will be same throughout the process, and direction of roll 2 will also be same throughout the process. It means the material will come in from this direction and will come out from this direction. In case of reversing direction, the direction of the roll mill can be changed. And let's consider if it is a reversing mill. So in initial condition, the material will come in from left side and come out from right side. But again, if we want to reduce the sheet thickness in a further way, then we can change the direction of this mill, and the material can come in from the right side also. So this is the advantage of reversing mills. It permits continuous reduction to be made through the same pairs of rolls. So this is what two high rolling mill. Now these are the combination of three high rolling mill. These are the combination of four high rolling mills. So what happened in three high rolling mills? Firstly, we use a combination of two rolls in the first stage. After that, for further reduction of thickness, we passes it through the combination of second and third roll. So this is how we use three high rolling mill. So this cycle is continued till the actual reduction is obtained, because we need a proper thickness, defined thickness of the sheet. And before starting the operation, we need to know the final thickness of the sheet, that how much reduction we want. So after that, we decide the types of roll mills that we are going to use. Now here, the disadvantage of this three high mill is to we need automation in this system. Without automation, we can't use this three high rolling mill. Now the four high rolling mill, in which we use four kind of rolls here. The smaller roll used to reduce the diameter of the seat, and the bigger roll used to support the smaller roll, so that the deformation and deflection may not occur during the whole process. So that's why we use this four high rolling mill. Now these are the cluster rolling. Cluster rolling are basically used where the material is too hard, and we need high force, and deflection is very must to avoid. Then we use such kind of arrangement. In industry, for increasing the production rate, we use tandem rolling mill, in which we use two high mills in a series. So this is basically tandem rolling mill. Now there are also we can also do threading with the help of rolling operation. So what we do, we have two die here, two fixed die. Okay, sorry, one fixed die and one is a moving die. And over the die, we have this threaded structure that we want to replicate over a you can say over a screw. So what we do, we have the workpiece specimen here, the starting blank, and we start moving the die. So what happened? The negative image of this thread just imprinted over the starting blank, and this is the final product that we get. So this is how threading can be done in rolling operation. Now the ring rolling is basically used to increase the diameter of ring. Basically, it is written here: forming process in which thick walled ring part of smaller diameter is rolled into a thin walled ring of larger diameter. The diagram is shown in the next slide. So consider this is the initial part, and it has certain thickness, and the diameter is also less. Now we want to increase the diameter by reducing this thickness. So in such arrangement, we apply some load in between this material in this thickness, and As the result of this applying load, the thickness reduces and the diameter of this ring increases. So this is a ring rolling operation. So till here we have discussed about the rolling operation and the types of different rolling operation. We have certain you can say the defects that we found after the rolling operation. These are the defects that we get. The first one is waviness. You can see it is not in a proper rectangular shape, or you can say the surface is not in planar manner. So this is waviness. This is formed if we use same kind of roll for very long operation. Then the surface of roll changes, and due to that the final product is not we cannot get the final product in a straight manner. Now the S center S, this is also defect of rolling operation, because the deformation of center is higher in terms of rolling as compared to outer surface. So that's why this thing happen. And again the cracking also occur. Cracking, if the material is not so ductile, then cracking may occur in the rolling operation. So these were some defects that occur in rolling operation. So till now we have covered all the different types of forming operation, and in next lecture we will start with welding operations. Okay, thank you.